All right, for the reminders, I just briefly walk you through. Please take a look, but nothing new. You can also check your e-class announcement. Let's do a very quick wrap up from before the study week, very quickly, and then we'll continue the topic. Okay, so last time we basically started with the discussion about equality in Java, which is a big topic, very important. We're going to take today and also most of Thursday as well. But I'll let you know maybe after today about which lecture like a material should be covered for a written test. But I already confirmed the slide range. There might be some example we talk about today that will be covered as well. I'll confirm. So we talk about using equals, right, last time. So if you use equals for primitive, it's going to compare just the values. But if you use the equal for reference, it's going to compare addresses. And the tricky bit really comes to when you actually got an equals method. Here's the tricky thing. The equals method is defined in the object class. And we said that object class is a very special class in Java. It is so-called a parent class for every class. You have no choice. Whenever you create a new class in Java, person, point, whatever, is going to be a child class of the object class automatically. Meaning that any method you define in the object class is going to be inherited to any class you define, including the equals method. So this is where your judgment is important. We'll go over more example today just to see how you can define the equals method if you want to. All right, so this is the first example. We say that if you actually just got point v1 class where we don't have any mention, any explicit declaration of the equals method, in that case, it can still actually call p1, which was declared as point v1, on equals method. Why is that? Because the equals method is inherited from the object class by default. Okay? If there's no explicit overriding or redefinition for the equals method in your class, you can just call the default version from the object class, right? That's very important for you to remember, especially for Friday's written test. And this is really the scenarios you also want to understand, right? We got two scenarios. Scenario number one, if you have a class where it does not explicitly redefine or override the equals method, you will simply use the default version from the object class, which will simply compare the references between the context objects and also the parameter, right? So that's the default version, which we already covered last time. And if you actually want to customize the equals method in your project, for example, in your lab number 3, that will be most of the cases. You want to kind of override or redefine the equals method. And then in your particular class, let's say point version 2, you have to first of all declare the equals method again, which is a public method returning a Boolean, and it takes a single parameter of type objects. All right, so that's very important to remember. And we got 4 different phases. We got phase number 1, phase number 2, which we covered before the study week. And also we got phase number 3 and phase number 4. So these are the 2 phases we're going to focus on today to begin with. All right? All right, and that's just about when you don't have the explicit mention about the equals method, you just use the default one from the object, right? We talk about the example. You can go over. And then we talk about call by value, which we also spoke about, right? I believe it's a Tuesday before the reading week. Call by value can be linked in this context in the following way. Let's say we have a call of the equals method. I say p2.equals p3. That means I'm calling the equals method. For example, I'm calling the equals method over here. Whenever you have a method call, you actually have a call by value relationship. And the relationship goes like this. Before you execute any line in your method that's being called, you actually got an explicit first line, which is going to do some variable assignments. And that one there is going to do parameter, which is obj, is assigned to the argument, which is p3. So this is why you can actually visualize the obj, the parameter, is simply pointing to the same object as pointing to by p3. All right, so that's a very quick recap about what we spoke about. Whenever you see the equals method here, how can you visualize what obj, the parameter, is pointing to? That's also very important for you to do the tracing. Okay? Are we okay with the call by value here? That's also very important. Okay. Okay, so we talk about phase number 1, phase number 2, right? Phase number 1 is just about if the context objects and the parameter, they are simply the same objects, then by definition, they are just equal. no matter what, because you're talking about the same objects. So the one object should be equal to itself. So phase number one is very trivial, trivially true. Okay? And for phase number two, which require a little bit of insightful discussion here, we say that if we are able to reach this line over here, in that case, if obj, the parameter, happen to be null, in that case, we simply return false, no matter what. And we said that in this case, you can refer to the recording to see the detailed discussion. Why are we not bothering if this might be null as well? In which case, we got null equal to null, which should be true. We don't really have that case, because if this happened to be null, you would have got null pointer exception when you try to execute the method call, right? That's something that you remember. So that's why we got this phase number two here, right? All right, so what we should do is about phase number three and phase number four for today, right? Any question from before the study week? All right. So phase number three and phase number four require a little bit, beg your pardon. It requires a little bit of look ahead about the concept that we're going to explore in way greater details when we talk about inheritance. But I want to give you one example, just enough information so you can actually see how these terms should be understood to understand the equals method. Okay? Let me remind you very quickly. So if you look at over here, phase number three is right here. And this is phase number four. And you will see two things that are kind of strange. Number one is, what does getClass do? The answer is it's trying to retrieve the dynamic type, so-called, for the objects. I'll explain that, what that really means. And number two, you can see we are doing obj parenthesis point v2. You may have seen something like this maybe in the first year. For example, if I have, for example, integer I is assigned to, if I want to assign 23.46 directly, I will get a compilation error because I cannot store some fractional number directly into the integer. What I can do instead is to do something like this. Do you guys remember what this is called? Cast. All right? Casting over here, from what you learned in 1022, 1021, that's all good. But when we talk about reference type, there's another scenario where you can use typecasting. Right? You will need that knowledge as well. But as I said, we are kind of look ahead what we're going to learn in greater detail inheritance. So I'll just give you some example just to understand exactly what the cast is really trying to do. Once we get to the inheritance series lecture, we're going to dive greater details into that. All right. Okay, so today we're going to do phase number three and phase number four. Let's now go over this example over here just to understand about several things. We want to understand about static type, dynamic type, and also typecasting. Okay, all these three. First of all, let's start with the static type. Static type in here simply means the type reference variable is declared to be. Or sometimes you can think about it simply the declared type. And let me say the most important facts you should know. Once you get a declared type, it determines the range of methods you can call on that particular variable. Okay? Once you get a declared type, it determines the range of methods that can be called on a variable of this particular static type. I'll show it to you. That's really important, static type. And we also got another thing called dynamic type. Oh, another thing I want to say. Static type, there's only one static type for each variable. Once it's declared, you cannot change it. Unchangeable. So the declared type over here, once declared, is unchangeable. Fixed. Oh, let me just say fixed. You can never modify the static type of a variable. On the other hand, dynamic type, well, literally, it simply means it's dynamic at the runtime. Dynamic type simply means it's like a runtime type. And this runtime type determines the version of the method that will be called on the variable. For example, for the equals method, should you call the version from the object class, or should you call the version from the point v2 class, right? It depends on the dynamic type. This will determines the version of method. That's being called. All right. For example, could be the equals from the objects, could be equals from the current class. Okay, and the runtime type may change as frequently as you wish. May be changed. All right. Finally, the typecasting. The typecasting over here, the most intuitive way to think about it is whenever I'm trying to cast a reference variable, I'm not really modifying its static type because static type, once declared, it cannot be changed. What I'm doing is I am basically creating an alias to the objects. For example, if I have some object over here, and then maybe the object has the reference v, let's say. And v was declared to be of type, let's say T1. So T1 over here is the static type for v, right? Declared type, static type, all good. If I want to cast v into something else, for example, I may say I want to now cast v, and the syntax will be parentheses, maybe I want to cast that into T2. Let's assume this cast is actually valid, okay? If I'm doing this, I'm not really modifying the static type of v. I'm not doing that because it remains to be T1. I'm basically creating an alias that's pointing to the same objects. But this alias over here has a different static type. Why would I need a different alias? Why would I need an alias of different static type? Simply because I want to have a different range of methods I can call on that particular alias. We'll see exactly how this can be done. All right? So this one here is basically an alias. Okay? So think about this as a typecast. Typecast of v is basically an alias to the same objects, but with a different static type. So these are the 3 terms that you're supposed to start learning. Okay, but we'll definitely dive into a little bit more into the theoretical rationale about why we should really have such a rule. But that's for later. All right, let's now go over an example here, just to apply what we have learned intuitively. Right? So we got a fragment of code right here. Let's go over one by one. Okay, let's be careful here. The first 2 lines, you can see that we got O1 and O2. Right? If you look at these 2 lines, you can see that C1 and C2 over here are the static type for, respectively, O1 and O2. So O1 has a static type C1. O2 has a static type C2. So these 2 are the static type. Dynamic type, the way to visualize it is like this. After the first 2 lines, you are basically going to get O1 pointing to some C1 objects. C1 objects, right? And also O2 is actually going to point to some C2 objects. Okay? If you like, you can also say O1 was declared to be C1. O2 was declared to be C2, right? Just be very clear. These 2 are the static type. And then right here is the dynamic type. So far, you're quite used to this name here and this name here always are the same. Not necessarily once we introduce you to inheritance. But we do have a little bit of inheritance that's involved right now. Remember, we talked about the object class. Object class is always the parent class for any class. Right? Just remember this relationship, for example. If you think about this is the object class, for example, is the parent class for every class. For example, the point v2 or point v1, right? Just to remind you, okay? But we'll just move on, okay? All right, so C1 and C2 over here, so these are the dynamic type. Dynamic type. So at this point, if I ask you about what's the static type for O1, C1? What is static type for O2, C2? What will be the dynamic type for O1 after this variable assignment? It should be C1. What will be the dynamic type for O2, C2? Right? So far, so good. Let's now talk about the method call here. That's interesting. All right? Whenever you want to see whether a method call will compile, you basically have to look at the static type. Remember, we talk about static type. Once you declare the type, it's going to determine the range of method you can call, right? All I got to do is, let's now say, when I call M1 and M2, whether or not I can do that, I want to look at the context objects, O1 and O2. Sorry, just O1 here, right? You can see the context object is O1. What is the static type for O1? C1. Static type is C1. That means the only callable method on C1, sorry, the only callable method on O1 will be those that's declared on C1. In C1 over here, we only got M1. So only M1 can be called. On the other hand, you can see M2 over here was declared in a different class, that's in C2. And C2 is different from C1, so we cannot call that. All right? So this is okay because M1 is actually declared in O1's static type. On the other hand, the second one, if you say O1.M2, this is not good. It doesn't compile because M2 is undefined in O1's static type. So that's good, right? So let me recap this rule, which is very important. Whenever you see a method call, whether or not the method call should really compile, you want to look at the static type for the context objects. Once you see the context object, you can see. Okay. All right, how about this one here? All right, let's do some exercise here right away. Can I say O2.M1 according to the rule? We cannot because you can now see that O2 being the context object here, the static type is actually C2. C2 only has M2 defined, so only this one is okay. But C2 does not have M1. It's actually in another class, right? So this is okay, but this is not okay. So I really want you to contrast this versus this. Depending on the static type for the context object, you may have something that compiles or does not compile. All right? All good. And let's now get object class into play. All right? Let's see. And then we'll gradually move to the cast. Let's now say we declare O3 to be of static type objects. So after this particular line, okay, let me just say that here. So after the start, O3 has the static type objects. So you want to think about whatever methods you can call on O3 must be declared explicitly in objects. Equals is one of them. So when you say O3.equals, it is okay. Can you say O3.M1? You cannot, because O3 has static type objects. Does object class has M1? No, it doesn't. M1 is only declared in C1. Can we say O3.M2? Also, we cannot, because M2 is only declared in C2, right? So think about a hierarchy here. I think I can draw a little bit better over here. Think about object here. Underneath it, we got C1 and also C2. And in the object class, we got the equals method. And in C1, we got M1. And in C2, we got M2, right? So that's kind of where the methods are distributed in different classes. All right. Okay, let me just complete that. So if you say O3.M1 and also O3.M2, both wouldn't compile. Now, okay, and let's now try another thing here. Let's say we declare O3 over here. And just remind you for O3, the static type is actually objects, right? Just remind yourself over here. And then I'm trying to do the following. O3 is assigned to O1. What does it do? It is trying to say O3 is now going to point to wherever O1 is pointing to, right? That's nothing new, okay? And now, given that O3 is really pointing to some C1 objects, would this compile? Given that M1 was declared in C1. Can we or can we not? If somehow you got misled by me, that's not good. I was trying to mislead you. All right, let me say that again. The following statement might sound logical, but it's actually not right. I was saying, after this line over here, O3 is actually pointing to some C1 objects, dynamic type. C1 does have M1 declared. So now at this point, I should be able to say O3.M1. It should compile. Sounds logical. However, the truth is, I will encourage you to also try this on Eclipse. It is not going to compile. The reason, go back to the definition for static type. Remember the range of method you can call on a particular variable like O3 is only determined by its static type. It doesn't matter what the dynamic type is. It's a very important fact for you. All right? So here, I'm going to justify here just to say not compile because O3's static type remains objects. Even though O3 has dynamic type C1, doesn't matter. Your Eclipse compiler only looks at the static type. As to why, we'll explore that a little bit later. All right? Similarly, can I say O3.M2? I also cannot, because O3 has static type objects. Object does not declare M2. M2 is only declared in C2, as you can see, right? So this one here also does not compile for the same reason. All right? Now, here comes the convenience of casting. In this scenario here, I know that my O3 here, despite its static type being objects, I know that dynamically it's really pointing to some C1 objects. I really want to call M1 because M1 is indeed defined here. How can I do that? Typecasting. For typecasting, you can actually change, well, you don't really change the static type. You can create an alias to it. Okay? So let's take a look at this line here. Okay, this is a typecast. Okay, so let me highlight it, and then we'll explore that line. So this is a typecast. I'm basically trying to say, okay, let me just be more explicit. This expression here. This typecast over here creates an alias. So what we do is we actually say C1 and then O3. This one here creates an alias of static type C1. So this particular alias has the static type C1. And that one there actually points to the same objects right here. So now, you can see two references point to the same objects, which has dynamic type C1. However, you cannot say O3 dot M1. It does not compile because its static type restricts that. On the other hand, for this alias over here, because its static type goes with the cast type C1, now you can call that method. So that is why this one here is going to compile. Because the typecast C1 O3 has the static type C1. All right? So I really want you to contrast these two. contrast this one over here, and also this one over here. Why? One of them compiles, but the other one does not. Okay, compare and contrast these two. Okay, and guys, this one here is somehow similar. Let's take a look at it. This line here. Should I compile? We are basically using the same typecast and .m2. Whether or not this method call should compile depends on the static type, right? What is the static type for this one here? C1. Does C1 have M2? No. As easy as that. All right? All right, finally, we can do a little bit, let me just finish that, right? Just let's try another one. Now I can try to do O3 is assigned to O2, all right? If I try this one, O3 is assigned to O2. What I do is O3, rather than pointing to over here, is now going to point to right here, right? After that variable assignment. Now, can I say O3.M2, given that it's pointing to C2? I cannot, because O3 is restricted by its static type objects. What I can do is I can now do typecasting. I can now try to cast O3 into C2, in which case the static type over here is going to be C2. I can definitely call M2 on C2, but I cannot call M1 on C2, right? Similar reasoning. I'm going to write down some brief explanation. I'll highly encourage you guys to really go over this example here carefully. I'll be more than happy to actually go over with some of them with you again, maybe tomorrow during the review session. But this one is important, okay? Okay, let's now make some very quick annotation. So think about this one here. This part, This part over here is the typecast, like an alias. An alias of static type C2. Because the static type is C2, which only has M2 defined. So this will compile, but this will not. All right? Let me recap about the rule you should know. Number one, whenever you see the variable being declared to a certain type, the declared type determines the method you can call. If the method you're calling is not part of the static type, it does not compile. Number one. Number two, dynamic type, it may change that whenever you like. For example, let's say, that's something I also want to mention. Okay, it's good that I catch that. Take a look at these two. Okay, so when I say O3 is O1, and also O3 is O2. Okay, so let's now say O3 star 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 star. So after the star, after I say O3 is assigned to O1, it's basically pointing to here. Dynamic type is C1. But after O3 is assigned to O2, I basically say rather than pointing here, it's now going to point to this object, and then dynamic type will be C2. So we are changing the dynamic type from C1 to C2. Okay. After star, dynamic type of O3 is C1. And then after star star, dynamic type of O3 is C2. But what about static type of O3? Always objects. That's what its declaration is. Right? Questions? Go ahead.
If you do O3 equals O1, can you then cast to C2 in that case, or no? That would compile.
You mean you want to cast O1 to C2?
O3 to C2 when you set it equal to O1.
So which line do you want to modify?
Do you see that first star, like the first purple line?
This one? Yeah.
2 lines down, you see that C1 typecast into O3? Yes, instead of C1, can't you do C2? Or actually, it would be better on the next line after.
Okay, good. The answer is yes, you may do that. Yes, you may do that. However, I would say that one will actually dive into something deeper about we may have something called class cast exception. But that's not something I would like you guys to worry. Okay? So the reason I'm talking about this example here, just focus on the scenario I'm setting up over here. That's just enough to help you understand about the equals method. Whether or not you're going to run into some class cast exception at the runtime, there will be some complicated rule that we're going to follow systematically. I'll rather delay that discussion once we get to inheritance. Okay? Yeah. So guys, what should you do for this example here? Go over the scenario I'm setting up over here. So whenever we got any typecasting, as far as now is concerned, we can cast the object static type to any type as we like for our purpose. All right? And later on, we're going to learn about how we can run into class cast exception, but not for now, not for today, and not for Friday's test. You don't need to worry, right? Just focus on this example. Okay? Any other questions? Okay. Having this in mind, let's now try to do some, let's now talk about phase number 3. Okay? So phase number 3 here, in some way, it's just about how we can understand about dynamic type. Let's now take a look. Okay? Oh, another thing I can also show you. Okay, let me just copy this. I think this will also help you. You will see there's something called getClass. So you will see, for example, you can see that here we got something called getClass and also getClass. GetClass simply give you a dynamic type for the variable. So getClass, whenever you say obj.getClass, it's going to give you the dynamic type of obj, right? That's the definition. And let's now just revisit this example here. I can have you a little bit more focused. Let's now focus on 3 lines over here. Line number 1, line number 2, and also line number 3, right? Only these 3, which we kind of already talked about. Let me visualize it. Okay. So before that, we already got O1 pointing to some C1 objects. Also, we got O2 pointing to some C2 objects. Right? It's actually from before. And then, let's now talk about different line. Number 1, number 2, and also number 3. And you want to draw a table over here, for example. Okay. So this will be the timing. So after 1, after 2, and also after 3. Okay? And then you want to see what is the static type of O3. Also, what will be the dynamic type of O3? Right? We're focusing on just O3. First of all, the static type after 1, after 2, after 3, after this line here, after this line here, after this line here, will all be the same. Just objects, doesn't change, right? Let's write it down first. All these are just going to be objects. Doesn't change, right? And then, when we first initialize O3, it's simply stored null. There's no dynamic type, right? So after 1, it's just going to be just null, which makes sense. And then, when we got number 2 here, O3 is now going to point to wherever O1 is pointing to, right? This is basically what number 2 is going to do. After that is done, dynamic type should be C1. And then, if we try to do number 3 over here, we say O3, rather than pointing to here, is now going to point to wherever O2 is pointing to, right here, right? So that will be done by step number 3. That one there, you can see is C2. So after step number 3, it will be C2. Right? You can see the evolution of that dynamic type. And the way you can get dynamic type is by calling O3.getClass. So that is the code you will see in the equals method. Okay, so this one here, you can say O3.getClass. So if I call O3.getClass right after step number 1, it's going to give me null. After step number 2, if I call O3.getClass, it's going to give me C1. And after this line here, if I call O3.getClass, it's going to give me C2, right? You see the idea. So getClass is a nice way to really retrieve the dynamic type if you want to compare, okay? Let's now take a look at phase number 3, right? Now that we have this understanding, okay? So phase number 3, we're saying that if the dynamic type for the context objects, compare that with the dynamic type of the parameter, obj over here. If their dynamic type happen to be not the same, then we just return false. That's what it is trying to say. So think about how we reach this stage over here. So what I would say is, think about what happens before then. We could have either returned from here or returned from here, but we didn't. So at this point, we know that, number one, this and obj, they are different objects. Otherwise, we would have returned true. We know that this and the obj, they are not the same objects. Okay? Number two, the obj here is not equal to null. Otherwise, we would have returned false. Right? Also, we know that obj is actually not equal to null. Having these two facts in mind, we are now checking to see if we are somehow comparing two objects of different dynamic type. For example, if you're comparing apple with banana, there's no comparison. You should just return false right away. Okay? I'll visualize that just to see how this can be understood. Okay? So the way to see this is like this. So we got this over here, and we also got obj. If this is pointing to maybe some object over here of certain dynamic type, and also we got obj, also points to another object here, but their dynamic types are different, just conceptually. Maybe one could be maybe just a triangle, the other one could be just a star. They're simply different. So when you actually got two objects of simply of different kinds of definition, different types, then we simply say don't compare them. Can you compare a string with a person? You should not be able to. Can you compare a vaccination with a distribution? You should not be able to, right? Just return false right away. Objects with different dynamic types are trivially not equal to each other. Okay, just say one more thing here. So this dynamic type over here, this is obj.getClass. And this dynamic type over here is this dot getClass. And we are saying that if we are trying to compare these two, whether they are equal or not, since their dynamic types are already different, there's no way you can compare them. Okay? Not really. Let's see some example right away. All right? So let's look at line number 9. Oh, by the way, we already covered all the previous line, right? Which is continue. Let's say line number 9 over here. All right? So we got P1 and also we got S over here. So P1 was from the previous line here, right? It's a point V2 object. So you can think about point V2 over here is the dynamic type of P1. All right? And that one there, it creates 2 and 3. All right? So now, which version of the equals method are we going to call? It's going to be determined by the dynamic type. So the dynamic type of P1 right here determines, so this one determines that the point V2 version of equals is invoked. And this is the point V2 version, equals method, right here. All right? And the arguments S over here, right? If you remember call by value, so S will now be alias to obj, right? Call by value. If you remember that, okay, let's see. Call by value. call by value. There's an implicit assignment. OBJ is assigned to S, right? That's what we said. So think about what's happening here is this. S is some string. So S pointing to the string value, I just say 2, 3 over here. And when you're passing this S over here, it's a method called OBJ. The parameter is going to be aliased to the same objects. So OBJ is aliased to the same object, right? That's exactly how things will work together. And now, how do we trace the rest of the equals method, right? Exercise for you, when you actually try to do these two, the branching condition over here, this branching condition and this branching condition will just be false. So we don't return just yet. Okay, that'll be exercise for you. On the other hand, when we reach this phase number 3, what's going to happen, right? Let's now take a look. This over here is going to be the context objects, which will be P1. What's P1.getClass? Point V2. So P1.getClass will be point V2. On the other hand, what will be obj.getClass? Obj.getClass is a string, right? And now, are they not equal to each other? Yeah, they are not equal to each other. So this here should be true. So we return false right away. All right. In some way, phase number 3 is pretty straightforward. You just got to remember you cannot compare apple with banana at the runtime. So all you got to do is, if you trace the code, just try to see what's the dynamic type for the object you're comparing. If they're simply of different sorts of objects, you just cannot compare them directly. That's exactly what this one's doing, right? So remember the get class over here is about retrieving the dynamic type, not the static type, but dynamic type. All right, question. So phase number 3 is only about dynamic type. And phase number 4 is to say, if somehow phase number 3, the branching condition is actually false, what does that mean if that's false? That means we're really comparing banana with banana or apple with apple. Right? That's something we're going to talk about in phase number 4. All right? All right. So why don't we take a very short break, and then by taking attendance, and then I'll continue right after the break. All right. So let's now talk about phase number 4. Right? Let's now think about how phase number 4 can ultimately be reached. That will be the final phase. Typically, you will the phase number 4 is the more interesting bit that you have to elaborate more for your own projects. Okay, let's take a look. Let's think logically here. If I'm able to reach phase number 4 right here, right? That's a phase number 4. That means all the previous phases would not have caused any return, right? If phase number 1 hasn't really returned, that means this Boolean condition must be false. So that means this and the objects, they are not the same. They are not the same addresses, number 1. Number 2, this condition here must be false as well. That means obj cannot be null, right? Number 2, the obj cannot be also null. And number 3, which we explained just before the break. So that means this one here is also false, meaning that getClass and getClass, which will give you the dynamic type, they should be the same. Okay. So this one here, number 3. So let me just write it here. So number 3 over here. So that means this dot, I'll say GC, getClass, right? Will be the same as obj dot getClass. Just make sure you understand if we're able to reach phase number 4, we got 1, 2, and 3 established. Okay? So now given that this and obj have the same dynamic type. So what we can do is, we can now do some casting. What's the dynamic type for this? This is really the context objects, which always has a dynamic type, point v2. All right? So point v2 is what we have over here. So this is by default the dynamic type of this, which is the context objects, right? If you think about what we're doing here, whenever you're maybe calling maybe some, okay, maybe not OBJ, we'll get there, once we get to the example. I think for now I want to keep it a little bit simple. Okay, let's now visualize the situation here. So what we have is, we have the this right here. That's a context object. Its dynamic type, by definition, is just going to be point v2. So this one will be point v2. So this will be the dynamic type of this. Let's start with that. Since we are able to reach this line over here, we know that this and OBJ, they should have the same dynamic type. Consequently, the way to visualize this would be, let me draw another one. OBJ also is pointing to some object over here. And then this dynamic type over here must be point v2. Otherwise, we cannot have reached phase number 4. This must be point v2. And let me just remind you, because we have reached phase number 4. All right, that's also very important reasoning to know. All right, since we are there, but now here's a question here. We definitely want to well, given that it's point v2 and point v2, we know that we actually got x and y over here. We got x and y, and also for point v2, we also got x and y. If I want to compare whether or not these two objects are equal to each other, I want to see if the x over here are the same, and if the y here are the same. That's what I want to do. Let me write down something to see if that might work. What I could have written is, let's say possible implementation. Let's say possible comparison. Okay. I might say this dot x equals obj dot x. X must be the same, and also this dot y equals obj dot y. Conceptually, we know what we are writing. However, will this be accepted by the compiler? That's a question. Let's look at that one by one. When I was trying to get access to x and y, and I got this right here. This one will be fine because I do have the x and y that was declared in the point v2. Not a problem. On the other hand, if I look at the axis over here, okay, let me use this one here. I got obj.x and obj.y. This one here is problematic. Whenever you want to call a method or call some attributes, so calling attribute and calling method, they are subject to the same rule. So obj here, what is its static type? How do you know? Exactly. So guys, that's a critical point. The fact that you declare obj the parameter this way, this one tells you that obj, the parameter, has the static type objects. Consequently, the range of methods and attributes you can call on obj is limited to the object class. Does the object class have x and y? No. X and y are only declared at the level of point v2, not in the object class. That's very important, right? So that's why these two are going to give you compilation error. Compilation, okay, I don't need this. Compilation error because x and y undefined in the static type of obj, which we know is objects. First of all, you cannot write this one here. So when I say it's a possible comparison, that might be what you're thinking, but you cannot do it. Give it a try. It might be actually worth trying to make sure it really doesn't work. What can we do? Well, because we know that dynamically, it's really pointing to a point v2 object, so I really should be able to access x and y. What we should do is typecasting. So what we do is we are now going to create some alias. So what we do is we got something called other. Other over here is going to be a cast version of obj. So what we got is we got other over here is pointing to the same object here. However, its static type is going to correspond to the cast type right here. Okay, so other over here has the static type point v2. And of course, obj here has the static type objects. Again, we got two different references pointing to the same objects, but they have different static type. That's really something new for you guys to know today. So once we got this, we can do other.x, other.y. Now it'll be okay. But if you say obj.x, obj.y, it's not okay. All right? Let's do a final annotation, and then we can look at some example. So this one here, the other over here, has the static type point v2, which is fine. All right. So now we have already covered all the four phases for the equals method, right? Let's just see more example just to see. Okay. Any question before we see some example? Yeah.
I'm just wondering, like, why in the equals method parameter, why don't we just declare the type that we want inside the object?
It's a very good question here. I wouldn't maybe dive in too much into it, but your fellow student has a very valid question. If we want to avoid typecasting, why can we not just put the desired type right here as a parameter? Maybe put that as point v2 as opposed to objects. The reason is we want to somehow make the equals method as general as possible. So we want to take any arbitrary object here and then decide whether we should return true or false. If you simply put, for example, point v2 over here, let's say if somehow we put another maybe string object over here, this equals method will not be even applicable. So we cannot even say we want to return false. Anyway, my point is we want to make this one as general as possible. That's also the Java definition. Right. Good question. All right, let's now go over two examples quickly. Okay. The first one, let's now look at P1 equals P2, right? We got P1 and P2. So we got P1 here, we got P2 over here. Their dynamic types are the same, right? You can see dynamic type are simply point v2, right? Point v2 and also point v2. 2, 3, and 2, 3. 2, 3, and 2, 3. And it's actually going to reach this particular line, right? It will be your exercise to trace them and see that all the branching condition from before is going to be false. So we don't really return prematurely. So what we do is we're going to create the other. Since we got P2 over here, right? So call by value, obj is just going to point to the same object as the argument, right? That's call by value, first of all. And then we are just going to create an alias called other. So other is actually going to point to the same object. The object is obj, but its static type is actually point v2. All right? So now we will be able to compare. So this .x, other.x, so this is P1. P1.x, other.x, 2 and 2 match. And also 3 and 3 also match. So this part here is going to be true. All right? Okay, hopefully that's enough tracing just for you to understand. But the most important thing is how you visualize the typecast right here. Right? It's an alias of for different static type. One more. And this one here, we actually got P2 equals P3, right? Let's take a look. So we got P2 over here, we got P3 over here. Very similar as before. As you can see, we got also dynamic type, point V2 over here. This one here and this one here. But this time we got 2, 3, and 4, 6. 2, 3, and 4, 6, right? You can see the P2 over here, P3. P2 has the dynamic type point v2. So we are calling this version of the equals in point v2. And again, exercise for you. We are actually going to reach this particular stage or phase right here. Right? So what we do is eventually we're going to get the other. So argument is actually P3, right? Oh, actually it's pointing to here. I beg your pardon. I just drew it wrong. Let me do that quickly. Okay. 2, 3. Okay. Let me do that properly again. Okay. So here we got P2, which will be 2, 3, and then we got 4, 6, right? And then we're going to reach the final phase right here. That's something we're going to get. And the other is just going to be an alias for P3. P3 is right here, right? Which is OBJ. So think about OBJ, the parameter is right here. And also we got other, which is also going to point there, right? That's a typecast. So that has the static type, point v2. And if you compare the two objects, 2 and 4, not equal. 3 and 6, also not equal. So it's going to return false, right? Okay. Similar idea. Again, I'm just visualizing in a different scenario. Just remember, we got the original arguments, we got a parameter called by value, and also we got a typecast, which is right here, right? So these are 3 different aliases you got to watch out for. All right. Well, for the remaining time today, I would like to just go over one important concept. Okay. Review in some way. Short circuit evaluation. Right? I'm pretty sure you guys heard about it, maybe from the first year. If no, hopefully yes, but let's now review that very quickly. Okay? And then we can look at some brief example. Okay? Let me start by saying comparing Java and math. In your maybe 1019 or 1090 when you learn about logic, so P and Q, right? That's conjunction, right? And also you got P or Q. And have you heard about something called commutativity property, right? I'll write it down. Commutativity. That one tells you if I got P and Q, that should be equivalent to Q and P. They really mean the same thing. However, in Java, you might be thinking, whenever I want to use the AND, I can just use %. Whenever I want to use disjunction, I would just use vertical bar. It's not exactly precise because these two do not necessarily satisfy the commutativity. So math and Java are not exactly the same. I'll illustrate to you. Okay? So now we got Java here. And we got P, %, and also we got P or Q. You might be thinking this can be turned into this, and this can be turned into that. Not necessarily. We'll see. So for example, so we have to cover something called short circuit evaluation. Okay, how does that work? All right. Let's now look at something called truth table. Okay, and then we'll see exactly how to compare them. Right, now I'll just do one example for conjunction, and for disjunction, similar. Okay, and that's the truth table for conjunction, right? So if I got true and true, that should give me true. If I got, for example, false and true, that should give me false, right? You know the truth table. We got 4 possibilities. Whenever we talk about short circuit evaluation, here is the principle. Number 1, evaluation should be from left to right. That means you should always, if I got something like this, if I got this and this, I should evaluate this one first, and then, if necessary, I'm going to evaluate the right-hand side. All right? So now, if you look at the truth table over here, there's something very interesting to see. The only case you can make the overall result true is when both of them are true. If either of them is actually false, it could be that the second one is false, or the first one is false, or both of them are false. In that case, it doesn't matter. You would just get false anyway. Right? So that's the property for the conjunction. So here is the rule. To evaluate if I got expression number 1 and expression number 2. First of all, evaluates expression number 1. If expression number 1 is already false, do I need to evaluate expression 2? I don't need to. The overall result will be false anyway. If E1 is already false, there's no need to evaluate E2. And then E1 and E2 is simply just false, no matter what. Right? It could be either when I know that this is already false, for example, it doesn't matter what this is. The overall result will just be false. Okay? And what if E1 is actually true? In that way, if this one is actually true, then it depends on what E2 is. Right? So I really need to evaluate E2. Okay? Okay, so number 2 over here. Oh, sorry, B. If E1 is actually true, then you must evaluate E2 to decide. Right? So we got 2 cases. Either E1 is already false, or it's actually it's true. These 2 cases, right? Maybe something you have already seen in the first year. Let's now take a look. So now what we want to have is, since we have some division and the denominator over here, we want to avoid division by 0, right? So we say that what you put on the left-hand side for the conjunction is so-called the guarding condition. All right, so this is something called the guarding condition. Guarding condition. It tells me that if this condition here, beg your pardon, if this condition here happen to evaluate to false, that way, in order to protect this expression over here, I'm not going to evaluate this one here. Just overall, it's just false. Okay, I'll write it down. If it is false. If it is false, that means x is exactly equal to 0. In that way, we will not evaluate the right-hand side, which is right here. Because if x is already 0, if I evaluate that, we're going to get division by 0. We don't do that. Okay? So this is some example you want to really go over, and then you can try it out, different values over here, right here and right here. Right? So there is one question related to this short circuit evaluation on the practice test. You can take a look, and then I think the range of slides we're going to cover for the written test will be the same. And for what I covered today, might be on the Friday as well, because it's kind of within that range. Right? I'll confirm again on the e-class announcement. Right? I'll see you there tomorrow in the review session.